Okay, picking up where we left off. Using graphs and functions, and I've been somewhat alluding to some of the things we're going to do, the relationship between points and functional values, but we're going to do a lot more with graphs and functions. Functions may also be represented graphically, but not all graphs will represent functions. To determine if a graph represents a function, we will use the vertical line test. And the vertical line test says the following. If any vertical line intersects a graph in more than one point, the graph does not represent a function. So, which of the following represent a function, why or why not? And again, I'm lecturing to an empty classroom, so at this point I have the class tell me which one was not a function. But this guy is not a function. Because notice if I happen to draw a vertical line, and I'm going to try to be pretty careful here and give you a truly vertical line. And I'm going to draw my vertical line, let's draw my vertical line right at 2. We can note that a vertical line intersects more than once, so not a function. Now, what this is picking up for us is this. So if I estimate here, it looks like that point there is about 2, maybe 1.25. Just really estimating. And down here, this point here looks like it's roughly 2, maybe negative 1.25, estimating. Notice that my x-coordinate of 2 appears more than once. One of the first things we said was something was a function if there were no repeated x-coordinates, if each x was paired with one y. And so when the vertical line test fails, so to speak, when it intersects more than once, what it's picking up on is repeated x-coordinates. My x-coordinate of 2 appeared more than once, so this thing is not a function. Now, you don't have to remember that that's how the vertical line test is working. What you need to remember is if the vertical line intersects more than once, you don't have a function, but what it's picking up on is those repeated x's. Now, if I go over here, this guy, notice any vertical line I draw, any vertical line intersects at most once, so it is a function. Okay, back to domain and range. Domain are a set of x-coordinates, range is a set of y-coordinates. We can use the graph to find domain and range. That's what we got down here. Graphs may be used to find domain and range of functions and relations. Remember, domain is the set of all x-coordinates, range is the set of y-coordinates. Domain, x, range, y. To find the domain of a function given its graph, form the interval or intervals from the leftmost x-coordinate on the graph to the rightmost x-coordinate on the graph. To find the range of a graph of a function given its graph, form the interval or intervals from the lowest y-coordinate on the graph to the highest y-coordinate on the graph. So we'll need to remember those in order to do the problems. Note, an open circle on a graph represents a single missing point on the graph. When there's an open circle on the graph is coming up to that point but does not include it. And we're going to see some open circles here momentarily. Okay, find the domain and range of each of the following. Now here I made these endpoints great big fat, so they're in your face sort of thing. That's just so we can observe them very closely. They're no more important than any other point. I just emphasize them. Okay, so domain. Domain is the leftmost x-coordinate to the rightmost x-coordinate. So I go over here. Here's my leftmost point. It looks like it's at -5, -3. So my domain is going to be -5. And over here, I have my rightmost point, and that looks like it's at 3, 5. And so my domain is going to be -5 to 3, square brackets, because I actually have an x-coordinate of -5, and I actually have an x-coordinate of 3. So square bracket. Range, and we'll do that in red. Range. Lowest y-coordinate to highest y-coordinate. So I go and look at the graph. There's my lowest point. And it looks like it's -4. Excuse me. -4, 0. So my domain's going to start at, I got that wrong. Pretend that didn't happen. My lowest point is 0, -4. So my domain is going to start at -4. And then my highest point also happens to be my right. Yeah, that happens. It's not important. But my highest point, 3, 5, I take the y-coordinate for range, and so my range is -4 to 5. Again, square brackets, because I have an actual y-coordinate of -4, and I have an actual y-coordinate of 5. Next picture. Okay, again, domain, leftmost x to rightmost x. So on the left, we have an arrow. And that arrow is going left and down forever. And the right, we got the same sort of situation there. I got an arrow, and it's going right and down forever. So leftmost, what I've got here is left forever. I don't have a number. I just have that arrow, and it's going left forever. That's what I care about on the left. It's going left forever. To right forever. So the way we're going to express that is -infinity to infinity. Left is negative, forever is infinity. Then range, and we'll get range, I guess, in here. Range, lowest y to highest y. Low, again, arrow. That's not how you spell arrow. I misspelled arrow up there too. I put 3 R's in arrow. Down here I was going to try to just put 1 R. Now I tried 3 R's again. We don't want 3 R's in arrow. It's going down forever. And notice it happens twice. It happens 2 places. My low is there and there. That's okay. I got low, I got 2 arrows. But both of them are going down forever. So down forever. then my highest is right there, 0, 4. I pick off the y coordinate, so 4. And so negative infinity to 4, square bracket on the 4, parenthesis on the negative infinity, because I always have parentheses on infinity or negative infinity. And there's my range on that one. Let's do it again. New picture. Okay, let's describe what's going up. Okay, so this circle right here, it's coming right up to that point, but not including it. But right, that's going to be the point 2,4. And that's also going to be my high point, 2,4. If I go and look on the left, I got that arrow, and it comes almost to the x-axis. All right, that's what, as far as I'm, excuse me, no, that's wrong about left. Ignore that. On the left, I have that arrow, and it's going left forever. And as far as low, again, I've got that arrow. But now I'm not thinking left, right. I'm thinking low. And as far as the low goes, almost x-axis, almost y equals 0. The x-axis has the equation y equals 0. So there I've just interpreted what's going on with that graph. On the right, it's coming up to but not including that point 2,4. On the left, it's going left forever. High, almost to the point 2,4. Low, almost to y equals 0. So now putting that into an answer domain. Leftmost x to rightmost x. On the left, we've got left forever, and then to almost 2. I pull off the x coordinates, but the open circle means I'm getting almost there. And so that's going to be negative infinity to 2, both with parentheses. My range, lowest y to highest y. Well, lowest, almost y equals 0, to highest, almost 4. So remember that open circle means you almost get there. Not quite, almost. And so my range is going to be 0 to 4, both with parentheses. So very important here to remember that for open circles, I'm coming right up to that point and not including it. So I get parentheses there to indicate the almost. And that's where we will end this lecture, or this video, not the lecture, the video.